Hello students, I am Divya and welcome to today's Explainer. Today, we are going to completely demystify a topic that, let's be honest, gives a lot of class 12th students a massive headache: indices and surds. I know, you look at these mathematical symbols on paper and they can seem super intimidating, especially when the pressure of board exams or competitive entrances is looming over you. But don't worry. In this explainer, we're going to take these scary-looking expressions and turn them into simple, fun little puzzles that you can literally crack in seconds. So here is our game plan for today. We're going to build your Math Magician's Toolkit step by step. We'll start by unlocking indices and surds, then move on to the golden laws of exponents, a super fun shortcut called the banana bonding trick, the absolute power of zero, finding the highest value, and finally, we'll wrap up by solving infinite series. All right, let's jump straight into part 1, unlocking indices and surds. We are going to start with the absolute basics, because frankly, building a rock-solid foundation is your secret weapon for acing those tricky mock tests. So what exactly are indices? Well, indices is really just a fancy mathematical word for powers. An index simply tells you how many times to multiply a number by itself. So say you have 2 to the power of 3. You're not doing anything crazy complicated. You're just taking that base number, 2, and multiplying it by itself 3 times. 2 times 2 times 2, which gives you 8. It's just repeated multiplication. Super simple, right? And that brings us right to surds, which fit into the picture perfectly because they are exactly the opposite. They're basically the reciprocals of those powers. For instance, if you take 8 and raise it to the power of 1/3, which, by the way, is just another way of saying the cube root of 8, you are just reversing the whole process. You get right back to your original base of 2. So powers build the number up, and surds bring it right back down to its roots. Moving on to our second section, the golden laws of exponents. Okay, these laws, they are absolute lifesavers. They're going to help you simplify those massive expressions that take up half the page in your exam papers. And what's really cool here is how logical it all is. You definitely don't need to blind memorize these if you just catch the pattern. First, for multiplication. If your bases are identical, just add the powers together. Done. On the flip side, for division, if the bases are the same, you subtract the powers. What if you have a power raised to another power, like x to the power of m whole raised to n? Just multiply those powers together. And finally, if you come across a negative power, don't panic. A negative power simply flips your number upside down, turning it into its reciprocal. Okay, section 3. This is one of my favorites, the banana bonding trick. So the real key is knowing how to manipulate these bases and powers. But what happens when you have an equal sign sitting directly between two terms that share the exact same base? This leads us to a brilliant shortcut. We playfully call it the banana bonding trick. If x to the power of m equals x to the power of n, then guess what? M must equal n. It is incredibly straightforward. If the bases on both sides of the equal sign match perfectly, you can just pretend they aren't there. Drop the bases entirely and directly equate the powers to find your missing x or y. Let me tell you, this trick saves so much precious time in competitive exams where every single second counts. Next up, section 4, the power of 0. We have got to talk about the absolute magic of the number 0 in maths. I absolutely love this analogy. If you take Mukesh Ambani's entire net worth and put a power of 0 on it, it instantly becomes 1. It really puts it into perspective, doesn't it? Mathematically, it literally does not matter if the base is in hundreds, thousands, lakhs, or crores. Any non-zero number, no matter how massively huge or rich it is, when raised to the power of 0, simply equals 1. It's like losing all your material power and just returning to a state of complete unity. All right, let's roll into section 5, finding the highest value. You know when you're looking at an exam paper and you see a terrifying comparison problem and you just freeze? Yeah, you're definitely not alone. Let's crack one of these together. Take this question. Which number is larger, 2 to the power of 72 or 5 to the power of 36? I mean, how on earth are we supposed to compare these without reaching for a calculator? Because you sure won't have one in the exam hall. We obviously can't multiply 2 by itself 72 times, but we can use a bit of logic. The real trick here is forcing those powers to become identical, and we do this using 3 super simple steps. Step 1, look at your powers. Here we have 72 and 36, and find their highest common factor, or HCF. Step 2, rewrite those original powers using that HCF to pull a common power outside a bracket. And step 3, once those outer powers are exactly the same, all you have to do is compare the new base numbers left inside the brackets. Let's actually walk through it step by step. For 72 and 36, a great highest common factor we can use is 12, right? So we rewrite 2 to the power of 72 as 2 to the power of 6 whole raised to the power of 12. Then we rewrite 5 to the power of 36 as 5 to the power of 3 whole raised to the power of 12. Now just do the quick math inside the brackets. 2 to the power of 6 is 64, and 5 to the power of 3 is 125. Now compare those final numbers. We are looking at 64 to the power of 12 against 125 to the power of 12. Because the powers are now identical, it proves instantly, without a doubt, that 5 to the power of 36 is the much larger number. See? No calculator needed. Finally, for our grand finale, Section 6, Solving Infinite Series. We're diving into the deep end now. These specific questions look like absolute monsters on an exam paper, but here's a secret. They're actually the easiest to solve if you know what to look for. Say you have the square root of 12, plus the square root of 12, plus the square root of 12, just going on and on to infinity. If you see a number repeating inside square roots like this, please take a deep breath and don't panic. We have a fantastic visual trick for this too. I like to use what I call the ocean analogy. Think of infinity like a massive, boundless ocean. If you take one single bucket of water out of an infinite ocean, what are you left with? Well, it's still the ocean. Mathematically speaking, if we set this entire infinite series equal to x, and we just hide the very first 12, the repeating part that's left over still goes to infinity, meaning it is also equal to x. This lets us substitute that whole repeating chunk with just x, turning an infinite nightmare into a simple quadratic equation. But wait, put your pen down. Because you've got your Math Magician's toolkit now, you don't even need to solve that long quadratic equation. There is a crazy simple two-step shortcut. Step 1, take that repeating number, which is 12, and break it into two factors that have a difference of exactly 1. For 12, those factors are 4 and 3, right? Because 4 minus 3 is 1. Step 2, just look at the sign in the series. Since it's a plus series, you simply pick the larger number. Boom, just like that, without any messy formulas. The answer to that terrifying infinite series is simply 4. It really is that easy when you understand the core logic playing out behind the numbers. You are now officially equipped with a complete Math Magician's toolkit for indices and surds. We've gone all the way from the basic laws to literally solving infinity. So I want to leave you with a final, slightly provocative challenge to test your new skills. What happens if that infinite ocean series of 12 was subtracting instead of adding? What if it was the square root of 12 minus the square root of 12 to infinity? Knowing what we literally just learned about picking factors with a difference of 1, which factor would you choose? Think about it, and let that concept stick with you as you prep for your exams. Thank you so much for hanging out with me in this explainer. Keep practicing, and I know you'll absolutely crush it.